The Dirt with me, Mike Howell, an economics podcast where I present the down and dirty agronomic science to help grow crops and bottom lines. Inspired by eKonomics.com, farming's go-to informational resource, I'm here to break down the latest crop nutrition research, news, and issues, helping farmers make better business decisions through actionable insights. Let's dig in. Well, hello again, everyone, and welcome back to The Dirt. We've got a special guest with us today to help us go through calcium and talk about the importance of calcium nutrition in crops. I was sitting at my desk a few weeks ago and was actually looking up some information for one of our previous episodes and just happened to look at the cover of my soil fertility textbook, and this man's name happens to be on the cover. Best I can tell, this textbook is used in just about every soil fertility class in North America. If you've taken soil fertility, chances are you've actually seen this man's name, Dr. John Halvin with North Carolina State University. Dr. Halvin, thanks for being with us on The Dirt. And if you don't mind, tell us a little bit about your background and what you do at North Carolina.
Thank you for inviting me. I'm thrilled to be here. I've been NC State since '96. I left Kansas State University, where I was a faculty member for 11 years, to come down here and be department head of the soil science group. And I did that for almost 10 years and decided I wasn't having any fun. I wanted to step back down and get back into the classroom and do some research and change my research focus from some ag crops to some grapevines, and so learn some different crops in that way. But anyway, I'm not originally from a farm. I'm from the inner city of Chicago a long, long time ago, but I got interested in agriculture as a young college student, got a degree in chemistry, and then between my bachelor's and master's degree, I'd married a young lady and then farmed her dad's farm for 4 or 5 years before I went to grad school, and then studied soil fertility and had the opportunity to write this book and do many other things. It's been a lot of fun. I've really been excited to have grown up in the last 50 years of U.S. agriculture. There's been so many changes in the last 50 years. Just one real quick one. When I was in school, we never learned anything about spatial statistics or geographic information. And then when I got to be a young faculty member at Kansas State, it became pretty exciting back in that was in the mid 80s, late 80s. So we were one of the first universities that research groups that actually quantify the spatial distribution, soil test phosphorus, and then plant a crop over that field, and then measure the spatial distribution of phosphorus uptake by that crop. And the maps fell on top of each other. So in 1997, we published that work that showed that you could quantify the spatial distribution in soil test nutrient, and it mirrors image the spatial distribution of that nutrient content in the grain. And that just turned us on to all kinds of great things after that. And of course, a lot of other universities jumped in the late 80s. This is before we had GPS units. You remember back in the late 80s, maybe you don't. Computers were huge. You couldn't sit them in a vehicle or in a little four-wheeler and so forth like they do today. Anyway, it's been remarkable, the changes that have occurred. I've also enjoyed watching the increase in production that American farmers have enjoyed and have contributed to feeding the whole world with their massive increases in yields per unit of land. It's been very, very exciting.
Yes, sir, it has been. I'm not quite as seasoned as you are, but I am old enough to remember a lot of those things you're talking about. So, Dr. Halvin, let's get to the dirt and talk a little bit about calcium today. What is the role of calcium in a plant? What's the function of calcium?
When I get asked these questions, or when I'm in a classroom and we start going through the various nutrients essential for plants, I always try to couch it from a perspective of how important they are to life on the planet. And if you think of calcium in your own diet and nutrition, what do you think of? You think of bones and teeth. You think of major structural components of life. And that's exactly the same in a plant. Calcium has major importance in the integrity and stability and strength of cell walls and membranes, and a lot of other things we'll talk about in a minute. Very important for cellular function, cell division. When a plant is deficient in calcium and you take that plant and you grow it in a solution that contains both sodium and potassium, it'll take up the sodium just like it does potassium. Of course, sodium uptake for most plants is not very good for plant health. But if you have adequate calcium in that plant, at the root hair, The uptake mechanism reduces sodium uptake in favor of potassium uptake, and so the plant is able to exclude sodium from getting into the plant when potassium is adequate. When it's deficient, then that mechanism doesn't work as well, and sodium just moves right on through. And so it's the integrity of that cell wall in the area at the root hair that's very important. Also, it is involved in translocating carbohydrates and other components, potassium throughout the plant. Potassium is taken up in the roots, obviously out of the soil water, as all nutrients are, and it's translocated up the xylem into the leaves. But once it gets deposited into the aerial portion of the plant, it's not mobile. It's not mobilized. If an area of the plant or a plant becomes deficient, it doesn't get translocated to the growing point, for example. If the plant can't continue to uptake adequate levels of potassium, then we have plant growth and health issues. And so since it is not mobile in the plant, generally we see issues, problems with the growing point. So degradation of the terminal bud, leaf tips, leaf edges, disformed leaves and disformed the new growth parts of a plant are very obvious with severely calcium deficient plants. Many growers out there are familiar with the term blossom end rot. That's an artifact of calcium deficiency that, again, it's the lack of translocation of carbohydrates and development at the end or the top fruiting bodies of the plant. And those cell walls and cellular structures are weakened and allows for disease, infection, and degradation of those materials. And so when soil pHs are low, highly leached, sandy soils, trying to grow tomatoes and peppers and all kinds of other vegetable crops on those kinds of soils, you'll end up with this blossom end rot. It's an easy fix. I've seen folks try to foliar apply calcium, and they just can't get enough into the leaves to solve that problem. Once you see it, it's almost too late. So it's more of a see the problem and then know you've got to fix it so that you don't see it again the following years.
Right. It's awful hard to get those foliar products into plants. That's true with a lot of nutrients we're dealing with. Dr. Halvin, how do you get calcium to a plant? If we can't do it foliar, what's the best fertilizer sources that we can use to ensure that we've got adequate calcium?
You know, it's an interesting nutrient. It is called a macronutrient, which means it's used or needed by plants in relatively large amounts. As a matter of fact, it's needed by plants a lot greater than potassium is and phosphorus is. Some plants need a lot of potassium. For example, my crop I've been working on lately, wine grapes, it needs more potassium than it does nitrogen. But for calcium, demands are pretty high. Legumes generally need a pretty decent amount of calcium. I was mentioning foliar application. We were doing a study on wine grapes. Just a little sidelight real quick. Growers don't like to put nitrogen on wine grapes because it makes the vegetative growth, the leaf area so big and so bushy that it creates in these hot, humid evenings and days, it creates the microclimate in the canopy that's very conducive to a lot of diseases. And so these growers end up having to fungicide spray and control these diseases by spraying about once or twice a week for about 3 months. So massive amounts of fungicides just to get a decent crop. They're deathly afraid of using nitrogen. Well, as an artifact of not using nitrogen, these plants are nitrogen deficient. And so the anthocyanins, the proteins, amino acids that get deposited into the grape skins are low. So the flavor of these grapes is bad. And so the product is poor from a quality perspective. We don't want to soil apply N because that will make leaf growth greater. So we did some work with foliar N. Now, crop needs a lot of N, but we could spoon feed nitrogen into that plant and got enough nitrogen into the grape skins to enhance the quality substantially. One could do that with calcium, but the problem is that calcium is needed throughout the life cycle of that plant. And in grapes, for example, I can develop the grapes and then wait until just before the green grapes turn purple called Veraison and start applying foliar nitrogen, and I get enough N in the plant to satisfy the demand, but without growing a lot of extra leaves. But with calcium, that's not going to be the case. If you were to foliar apply calcium, you'd have to try to run out there and foliar apply on a weekly basis, and that's just not practical. So to answer the question is you've got to use the soil applied, mostly pre-plant applied. Liming will take care of that problem. So liming your soil to the target pH is probably the best management for calcium that you can do. There are other crops like peanuts, we'll probably talk about that in a little bit, that are special case as well as some other crops. But there are other sources. A lot of misunderstanding about liming and pH and base saturation and all those terms, and a lot of variation out there between soils. And a lot of folks question exactly what's the right thing to do. And hopefully here in the next few minutes, we can help them out with understanding calcium, pH, and all those parameters that one has to look at to make decisions on how much lime to apply.
Well, Dr. Halvin, you're kind of hitting all around my next question. And can you talk a little bit about the relationship between calcium and pH? Can we have adequate calcium in the soil and still have a low pH? Or can we have an optimum pH and still need the addition of calcium?
Michael, that's an excellent question. It's a longer answer than we probably have time for, but let me hit the high points that hopefully will make it a little easier to understand. The relationship that's tried and true is that between soil pH, parameter that's on every soil test report ever produced anywhere in the U.S., called base saturation. It's the percentage of the cation exchange capacity, the total ability or charge in the soil that enables the soil to hold on to cations. And those cations are bases. Basic cations are calcium, magnesium, and potassium. In an acid soil, the remainder are generally a little bit of acid, mostly aluminum, which is the thing we're trying to reduce when we buy liming. In high pH soils out in the Great Plains, for example, where their pHs are above 7.2 and so forth, why there isn't any exchangeable aluminum, but they do have more exchangeable sodium. So those are the basic cations. So as pH goes up, the percentage of the CEC occupied by these basic cations goes up. So in North Carolina soils, for example, a lot of southeast soils, this would be true in your area. This is a generic, just average value. It varies all over the place, but this is an average value. If you have a pH of 5, you're about 50% base saturation. So 50% of whatever the CEC is, 5, 10, whatever the cation exchange capacity is on your soil test report, 50% of that are these good essential plant nutrients we call bases. Calcium, magnesium, potassium. The other 50% are acids. And when you're at 50% base saturation at pH 5, unless you're growing blueberries or other plants that love acid soils, you've got to increase that pH. And the way to do that is add a salt that has an anion that neutralizes hydrogen in the soil solution. Carbonate plus hydrogen, when you combine those two together, gives you CO2 and water. The hydrogen in solution goes down, the pH goes up. And the calcium that you've added in the lime goes over to the CEC and says, I see aluminum over there. So it knocks that aluminum off, and the aluminum goes into solution. And when the aluminum is in water, it reacts with water and produces some more hydrogen. Well, that makes it sound like the pH is going to go back down, and it would, except for we have a lot more carbonate from the lime we applied, waiting for that aluminum to produce that hydrogen, and that's when the pH goes up. So there is a very strong relationship. It is not the same in all soils, but when I raise pH up to 6, for example, from 5, pH 5, 50% base saturation, to pH 6, I now am at 80% base saturation. That's generally okay for most agronomic crops. Yes, there are some crops that need a little higher pH, a lot of legumes and so forth that need a higher pH than 6, but that usually does well enough for most agronomic crops. When I see a soil test report and I see pH 5, 50% base saturation, red flag, I know I need some lime. And the question is, well, how much lime is it going to need to get it up to 80% base saturation and raises to pH 6? So the question you're asking now is specific to calcium. How does just calcium vary with pH? Well, at that pH 5, 50% base saturation, I could have most of that as calcium. As a matter of fact, most of the basic cations on our soils is calcium. And if you think about life on the planet, most of us running around, including the plants, are loaded with calcium. And there's a reason for that, because we eat plants and animals that ate the plants and so forth and so on, and that's where they got a lot of calcium from our soil. So that's the dominant cation on the CEC is calcium. So some folks say, well, the optimum percentage of the CEC that should be calcium is about 60 to 80. Well, that's not true in all soils. I go by base saturation. And once I got base saturation and pH where I need to look to see what the distribution of the calcium, magnesium, potassium are. So I look at that, and my general rule, it's actually in the textbook, it's a Halvin general rule. If you see the percentage calcium of the CEC less than 25%, that's a red flag for calcium deficiency. They are very rare. I'm up and down the roads and fields all the time in North Carolina and surrounding states, and I very rarely see calcium deficiency. But the other cations, magnesium and potassium, they can be low as well. So as base saturation goes down, those two can go down too. My rule of thumb is if magnesium is less than 3 or 4% of the CEC, I have a potential for magnesium deficiency. And if that magnesium percentage is 3 or 4%, then my choice of calcium source when I'm liming is dolomitic lime that contains the magnesium in it. So I don't have to apply magnesium, but with some other product and make another pass over the field. It's very important before I buy a lime product to make sure my calcium magnesium ratios or relationships are okay. Magnesium's not too low. Liming will obviously raise calcium. My general rule of thumb is when magnesium is less than 3 or 4%, then there's a potential. Not saying it will happen, but there's a potential for magnesium deficiency. And the higher the calcium is above that 40, 50%, and magnesium is really low, then you increase the potential for magnesium deficiency. And when that gets down to 3 or 4%, when I'm trying to decide on a liming product, I always go with dolomitic lime that contains more magnesium, so that I can bring up calcium and magnesium together so they don't get out of whack between each other. So again, in our soils, I've seen wonderful production of all kinds of crops on 40% calcium, 20% magnesium, 1 or 2% potassium, pH is 5.8, good to go. But if you're trying to plant a legume, soybeans, it's probably too low pH. I probably need to raise that up. So I try to get things up, not by percentage of calcium, but by base saturation, and make sure the calcium, magnesium doesn't get too low.
Thank you, Dr. Halvin. That's a lot of information to go over there, and I hope our listeners are paying attention. That's some really good information. Dr. Halvin, you briefly mentioned peanuts. One of my previous jobs was peanut specialist here in Mississippi, and we did a lot of work with peanuts, and most of the growers applied some gypsum about pegging time. Talk about gypsum and how we can get calcium out of gypsum and why we need to do that, especially in peanuts.
That's, again, when we talked about how calcium moves in the plant, you're at a growth stage when the pegging starts. The plant has a relatively high demand for calcium. It's a little later in the season. The surface soils are a little dry. Water availability is a little lower. So plant available water is marginal probably. And those little roots coming out of that pegging process aren't going to find enough calcium. So research has shown that if you apply a little gypsum at that time, that'll meet the calcium demand and does enhance yield. Long-term yield responses in North Carolina are somewhere in the neighborhood of about 20 to 35%, depending upon the year and so forth. My good friend David Jordan tells me all the time that it's just a matter of general practice to apply gypsum at the pegging stage with peanuts. You have raised pH of your peanut field to 6 or 6.2, but that's still not enough calcium at that time of the season to meet the demand for that plant. And so unfortunately, you're just not going to be able to foliar apply this calcium and get enough calcium in the plant to meet the demand. So soil applied is the best way to go.
I'm glad you mentioned the foliar applications. When I was with Extension and working on the peanuts, I can't tell you how many different companies came to me with a liquid calcium product. And you kind of do the math on some of those products. In order to get the amount of calcium you need, you were going to have to put out 50 gallons of their product to the acre. It kind of made you wonder if you were getting a benefit from the calcium or by that much water in that dry period of the growing season. And I never did really get any yield responses on any of the liquid calciums I put out. Have you used a lot of those? Can you tell us anything more about that?
Not on peanuts. Very good question. NC State Extension recommends about 1,300 pounds of gypsum. And if the gypsum contains about 21% or so calcium, that's equivalent to 270 pounds of calcium, 21% of 1,300 pounds. Calcium sources vary all over the place. You got flue gas gypsum, you got phosphogypsum from the phosphorus fertilizer plant. You got all kinds of products. You just got to look at the label and look at the purity and how much calcium sulfate's in there. But Dr. Jordan tells me that if you use the liquid calcium, and that's usually calcium chloride, and he came up with this 12% calcium product, and I've seen many products with 10% calcium in it. He said, I only need 23 gallons. Well, I did the math. He says there's about 12 pounds of calcium in a gallon. That makes no sense to me because a gallon of water weighs 8.3 pounds. Well, by the time you put the salts and the chelates and stuff that are in these liquid calcium products, you're about 10 or 11 pounds per gallon, just kind of like 1034O density. Well, if the product weighs 10 pounds, you can't have 12 pounds of calcium in it, all right? So his math wasn't right. I redid the math, and to get the equivalent of 1,300 pounds of gypsum, I would have had to put on 250 gallons of this 10% calcium product. Well, I looked up the latest price is $10 a gallon. So you can see that it just makes no sense. Now, I don't want to disparage liquid calcium products because they have their place. If I have a blueberry production field where I don't want to raise pH and I'm starting to see later in the season as the fruit's starting to develop a little calcium stress, I can foliar apply calcium. Might have to do it 5 or 6 or 8 times, but I can foliar apply calcium, and there's a role for some of these products. But for peanuts, it's not a viable option.
Dr. Halvin, I appreciate you going through that, and we've discussed on some of our previous episodes about some snake oils, and I put a plug in then for the universities and the extension specialists. I want to do that again. I encourage growers to get to know your university extension specialist and your county agents. They're the best source of information out there to find out if a product's going to give you a benefit. You want to make sure you're getting a return on that investment, and we've also talked a lot this season about the increase in prices of all commodities. It's important this year that you know where every dollar you're spending is going to go and what you can get out of that dollar. Dr. Halvin, we went over a lot of information today, and I know it's a lot for growers to digest. Is there anything else that we need to talk about on calcium before we wrap this up?
We were talking about liming and alternative products. I just want you to be aware that there are products out being marketed that suggest that if you buy this product at 2 or 3 times the price of ag lime or even pelletized lime, that you only need a quarter of the rate. And I've looked at these products and looked at their label. If you know how to interpret a lime product label, the CCE and the fineness factor, and do the calculation, quarter of a rate is just bad marketing. Still, you can't go cheap on lime. If you need a couple tons of lime, you've got to do it.
We've got to get that soil pH right, and that's one thing I always stress to growers. When I was with Extension and looking at soil samples and fertility recommendations, that's the first thing I recommended they do. Spend the money and get your pH right, because it doesn't matter how much money you spend on the other stuff. It's not going to work if you don't have that pH right.
And raise the pH a little higher than an average value, because there are areas in the field that are going to be lower than the average, and you'll be underliming those areas. So make sure if you're trying to get to pH 6, just make it to 6.2 on the average, and you'll get some of those low areas that might be at 5.6 or something. That's why variable lime application really pays.
Dr. Halvin, we really appreciate you joining us today. We've got a lot of good information from this. Listeners, thanks for tuning in this week. I hope you enjoyed our episode today with Dr. Halvin and learned more about calcium and calcium nutrition in plants. We want to remind everyone, if you will, please pass this edition along to your friends and neighbors. And if you would, please like our program and give us a rating, give us some feedback as well. I would like to invite everyone to tune in next week when we visit with Mark Tully. Mark is an economist with Nutrien, and he is going to be talking about different factors that are affecting the commodity markets today. Until next time, this has been Mike Howell with The Dirt.